work. I need to update it also. Sorry for that. So just let me go to the material. Here is the one I want to show you. So I just go to the local version so I can run the code. I talked about the definition of the vector and matrix. I think it's easy for you, right? Here is the Python list. We define it as a NumPy matrix, NumPy vector. Sorry. Actually, all the vectors and matrix here in NumPy are called array, NumPy array. So yeah, so I just give you this information. And also I define a two-dimensional matrix here. Oh, here I have an interesting question for you. Just like, sorry, this is not two-dimensional matrix. Let me correct it. This is two-dimensional matrix. Anyone can tell me, this is not mathematical question. It's like just in case you will be confused in the later stage, because you will see dimension in a lot of places. In GeoAlgebra, in NumPy, and in data, you will talk about data dimension. They are all different. They are all different. So I want to ask you why it is called two-dimensional matrix. Is it because the number of rows? The row is like the number of example, right? Or is it because of the number of column? Columns is like features. Always think it in this way, in this unit. Yeah, you can't open this thing. My fault. Sorry, I will. Column rows. Wow, that's a good caveat for a lot of people. Yeah, none of them. Because great, Barons, that's great. Yeah, it's because it has column, it has rows. So, and I know it's maybe a little bit abstract, so I make it concrete for you. How about I make it 3-dimensional? What you need to do is add another inner list in that. This, you know, it still look like 2 row, 2 column, but you make an inner list here. You have a 1 level of list, 2 level of list, 3 level of list. So now it becomes 3-dimensional matrix. Okay, so it because you know how hierarchy of the data, not hierarchy of the data, hierarchy of the data structure. Okay, it's about data structure, not about data. Okay, let me ask you this question. How about if I say I have 2-dimensional data? What does it mean? It means the number of rows or number of columns. Column is feature, rows are example. Every value is organized into rows, and if you use the rows and columns, the idea is only exists in 2-dimensional matrix. If you use 3-dimensional matrix, you shouldn't define it as column and row. If it's like yeah, just yeah, but that's okay because we only take about 2-dimensional matrix in this unit, only column and rows. So back to my question, what make 2-dimensional data 2-dimension? It's because of the number of features, or because of number of examples, or it because of something else? Nope. Okay, it's because of the number of features. Normally we see we have 2-dimensional data, we have two features to describe this data. That's the thing. Like say, I want to describe Baron and Amma. I will give the feature like your height, your weight, your gender. You know, this three-dimensional data. If you will only give the features of height and weight, is two-dimensional data. Hope you are clear. And another things about dimension is the dimension in linear algebra. That will be quite complicated since I won't talk about this because it doesn't matter here. Although I say this is a linear algebra tutorial, but I didn't explain the dimension to you for linear algebra. But I can recommend you to go to the YouTube video in 3 blue, 1 brown. Yeah, this YouTuber has awesome understanding, visualized understanding of dimensions of, you know, of the for linear algebra. Okay, so I will go forward. Why this windows always pop up? Each feature is like an axis in graph. Yeah. Because 2-dimension and 10-dimension have the 10 feet. Oh, yeah. Oh, great. Can't be shown in 2D. Yeah, I'm not sure what do you mean for can't be shown in 2D. If you, I think you understand it. But just to avoid confusion, if you have 2-dimensional data, you still can represent it in 2D matrix. But I think Baron is doesn't mean that. But that's all good. I just clarified that. Because you know the number of column is featured, so okay, transpose this things you will encounter in your assignment. Let's now actually I want to talk about, you know what's a matrix, you know what's a vector. I want to talk about the operations of vector and matrix. Remember, now we define this, you know, this is Python list. Why not just use Python list rather than to give this Python list to a lumpy array function? You see, this is, if you print it, it seems like the same thing as Python list. The reason is because if you define it as this lumpy array data structure, you can use a lot of operations for as vectors. Like say in linear algebra, one operation is transposed, right? You can just use something like this, then it will work. It's too messy. And I will not talk too much about transpose because it's easy thing. It's like, let me go to 2-dimensional matrix. So it will be good for you to look at the output. Just show the result. You will know what's the transpose. Oh, the data is play with me. You can see now this is original data. This is transpose data. Sorry, I shouldn't say data because you know matrix can be data. Matrix can be models, can represent the model parameters. Here is a matrix. When I use the transpose, these rows becomes the column. This second row becomes the second column. That's it. So easy. Just no need to go to detail about transpose. But I will go to the detail of transpose when I'm talking about PCA. Principal component analysis. We need that for PCA. PCA is algorithm for for dimensional deduction. Sorry, dimensionality deduction. Yeah, but the most common operation is not transpose, is multiplications. Anyone know what's a dot Oh, sorry, I running out of time, so I just give you the answer. When you run the dot products, as I say, when you define it as lumpy function, lumpy array, you can directly call the dot methods. Methods is just a function attached to the Python class, Python objects or Python class. So now you can do something like this. How they do this? They multiply the first element together, the multiply second element together, so you get 1, you get 4, then you plus them, you get 5. That's it. For the matrix, what you do is you multiply the first row with the first column, then you get the result as the first row and the first column. Same thing, if you multiply the first row as the second column, then you get the result for the first row and the second column. This is 22. Hopefully it will be understandable. Yeah, sorry, I don't have time to ask this question for you. Actually, I want you to tell me. Yeah, this is very, very important operations. Please take some time for this, because if I have to say one thing you have to know in linear algebra, dot product. Element-wise product, that's easy. It's not often to be used in this unit, but just let you know. You just multiply this and this, this and this. You know why it's called element-wise? Because you match the values at the corresponding position. 3 times 7, 4 times 8, then you get this result. Yeah, I don't want to do, yeah, this is a matrix multiplication. Actually, it's dot product. And this is not good contents. I just play for. Just let me delete it. Yeah. Okay, remember what I said before. Dot product is very important, but dot product can be performed between vector and vector, matrix and matrix. I told you before, but now I want to told you that normally we will use it between vector and matrix. The vector represents one data, one example. Matrix represents the modeling part. We want to transform the data towards the goals you want to know. It's like in classification, in supervised learning, you want to know what's the sentiment of this Amazon reviewed. So you need to transform this sentence. This sentence will be represented by a vector. And then this matrix will transform this vector towards this, this towards the goals of the sentiments. The goal is the sentiment, right? So here is a simple example. Now I have a data point here. This data point is this is two-dimensional data, right? Because 0, 1 is a plane, can represent 2 dimensions. So now I want maybe the correct results. To achieve the correct result, I want to transform into this point. How you can do it? You have 0, 1 defined here. You want to get, you have 1, 0. You want to get 0, minus 1. So I have figured out the matrix for you, but normally this matrix is learned from data. So if you run it, this matrix will transform this original data point to the transformed data point. A concrete example is large language models. This is a large language model representation after transform the language. You can see this is a prepositional phrase, is a verb phrase, is adjective phrase, noun phrase. You can noun phrase a prepositional phrase organized together, and if we visualize it in the plane, you can see this linguistics component class together. This linguistic component class together. This is how this language is transformed into more abstract, meaningful semantics by the matrix, by the function, by the linear algebra things. Shouldn't call linear algebra. If you use neural network, normally the whole function is not linear, but if you take, so it's algebra things. Hopefully it's understandable.